Okay, so here is our first argument that we're going to do a natural deductive proof of that utilizes the various 13 rules that you've just been introduced to, okay? Again, I'm going to use the bottom-up method, okay? And as with all methods, whether or not it's top-down or bottom-up, the first thing you want to do is look at the conclusion, okay? Then what you want to do is see if you can find the conclusion as it is given or parts of the conclusion in the premises that are given, okay? So notice how here we have T dot R, and we have T here and R here, and we have T here as well, okay? So now what you want to consider is possibilities, okay? How is it that you can get T dot R from either of these parts, okay? Well, one strategy is this. Remember, if you use conjunction, if you can get T on its own line and you can get R on its own line, then you can conclude, okay, the conjunction of T dot R, okay? So if that's the case, okay, then we have to ask ourselves, well, do we have T and do we have R as premises that are given to us, okay? And notice how we have R here, and we have T here and here as well. We don't have them on their own line as their own separate premise, okay? So we don't have T and we don't have R, which means we have to look for or get T and R on its own line before we can make this as a conclusion using conjunction, okay? So here we're going to have now a bifurcated proof because we have to look for T as a conclusion, okay? And we also have to look for R as a conclusion before we can conclude T dot R using both of these as premises, okay? And you should start with one side and then the other, okay? Don't try to do both at the same time, okay? So let's start with T. Now again, we look at what we need, T this time, and look at what we have, okay? And see if we can find either the statement as it is given or parts of the statement. In this case, there's no parts since it's a simple statement, okay? In the premises given. Notice how we see the T here and the T here, okay? So maybe we can get the T from this statement here or this statement here. But which statement would we use? Well, you should consider the fact that this statement T is part of a conjunction, okay? So it would be really easy to conclude T from this conjunction using simplification, whereas this statement T is inside parentheses with a negation on the outside. So before we can use that T here, get it on its own line, we're going to have to get that negation away from outside that parentheses. So using the T here will be more complicated than using the T here, so might as well just go for the simpler solution, okay? So we can actually use the statement 1, T dot S wedge R, okay? And from this, we can actually immediately conclude T using the inference rule of simplification, okay? So notice how here, this conclusion ended by using only a premise that is immediately given to us as a premise in the argument, okay? So premise 1 is given to us, okay? So I can actually stop looking for anything else here because once I have this, I can get this, okay? Which then gives me this, okay? However, we need R still in order to continue on to conclude the ultimate conclusion we want. So now this ends, but I need to get R, okay? So now what we want to do is figure out how is it that we can get R, okay? And again, we look at what we need, in this case it's R, and we look at what we have, and R only occurs here in this statement 1, okay? So you can kind of make a hypothesis. Well, look at this. R exists inside the parentheses of a conjunction, okay? So it would be very simple for me to get S wedge R by itself, okay? So if I had S wedge R by itself, okay, can I possibly conclude R using some other premise and an inference rule? Well, if I had used disjunctive syllogism, okay, then I would be able to conclude R, okay, as a conclusion if I also had not S, okay? So if I had these two statements here, okay, then I could use disjunctive syllogism to conclude R. And now the question becomes, do I have these two statements here? Well, I don't have them as they are given, okay? So now I have to look for them. So again, I will have bifurcation, okay? I have to look for S wedge R as a conclusion, and I will have to look for S as a conclusion. So again, we're going to start with one side and then move on to the other side. Okay, so let's start with here S wedge R. So notice here again, we don't have S wedge R as it is given, but we have S wedge R here, okay? And it is part of the conjunction that is premise 1. Because S wedge R is part of the conjunction here, it's actually very easy for me to conclude S wedge R using simplification, okay? However, when you use simplification, simplification allows you to conclude the first conjunct, okay? So if that's the case, I need S wedge R to be in this position rather than this position, okay? So what I actually need in order to do simplification is S wedge R dot T, okay? And I don't have S wedge R dot T as of yet. However, I do have this statement here, T dot S wedge R, okay? And S wedge R dot T can actually replace this statement here, T dot S wedge R, by using the replacement rule of commutation. Okay, so I can go from the statement 1, T dot S wedge R, okay, to the statement S wedge R dot T, okay, using the rule of commutation. Okay, and notice how here I end with a premise that is given to me immediately, okay, in the argument I'm providing a proof for. So I can stop here, okay, because once I have this, I could get by commutation this as a conclusion, and once I have this, I can get this as a conclusion, and then from here I can go here. Now remember, we had two branches here just like we had two branches here, okay? So before I can continue my proof and write it down, I'm going to actually have to finish this half of the proof here. So remember here, what I need to get is an S. However, we still need to get, remember, the not S here. So this side here allowed us to eventually conclude S wedge R, which is this premise here. But remember, we also need this premise here, not S, as a conclusion on its own line in order to derive the R here. So now what we have to do is look for the not S. Now in order to get this not S, we have to see if we can find it as it is given or parts of it in the premises given. Notice that we have an S here and an S here. In neither case do we have a not S, okay? However, if you look here, you'll see that this S is inside the parentheses, okay, of a conjunction with a negation on that outside. This means that we can actually use De Morgan's law to turn this S into a not S, okay? So here now we can try the top-down strategy. Once we've gotten to this point, okay? Because we're working with a premise that is immediately given to us, okay? So we can try to figure out, well, what can we do with these premises that are immediately given to us so that we can end up with more statements that we can use over there, okay? So on our third line, let's go ahead and take premise 2 here and apply De Morgan's rule on it, okay? So then we'll end up with not T, wedge, not S, okay? And here, in order to get this statement, we actually used statement number 2, okay, and De Morgan's, okay? So we were able to replace this statement with this statement here on line 3, okay? Now notice that we have not S, okay? And we want basically to get not S as the conclusion over here, okay? So you can hypothesize now over here, well, if we use statement 3, okay, which is not T, wedge, not S, then perhaps by disjunctive syllogism, we can conclude not S. But in order to do that, we're going to have another statement. And that statement will be not T. Okay? So we're going to have the negation of the first disjunct. Okay? The first disjunct is not T. So in order to do disjunctive syllogism, we're going to have the negation of that, which is not T. Okay? So ask yourself, well, do we have not T or part of that in what is given to us? Now notice how here we have, okay, we have T here, okay, as part of the conjunction, and we have ultimately T inside these parentheses. To use that, we'll have to use it like this, and we have not T, okay, here, okay? But this is part of a disjunction. Okay? So the best thing we'd probably want to do is to use the T that's part of this conjunction here, because we can take that T out, okay? So again, now we're working top down, okay, with our eye on what we need to do over here to get the not T, okay? So for our fourth line, we're going to take that T out of the conjunction using simplification. So using simplification, we can conclude T, and our premise that would use is premise 1, and we would use the inference rule of simplification. Then, once we have T, we can use our replacement rule of double negation to turn that T into not T, okay? So we got not T from 4, and replacing 4 using double negation, okay? So now notice we have not T, and what we wanted was not T, okay? So not T is then our statement number 5, okay? So now we have ended with all our premises on this side, okay, being rooted in the premises that we have already been given or derived in our proof, okay? So remember, once you write statements down as conclusions in the proof, you can use these for subsequent proofs, okay? So we can stop, okay? We have finished doing our work, okay? In this case, using first the bottom-up method and then at a certain point going top-down, okay? So here, our work kind of meets in the middle, okay? So this is from the top down, this is bottom up, so they meet in the middle, okay? And ultimately, we're going to conclude T dot R, okay? So now that we're done doing all our scratch paper work, we want to finish writing down our proof. So in order to finish writing down our proof, okay, we can start from this side over here. Remember, you want to write from top down. Since we work bottom up, when you write down your proof, you write it top down. You can start here if you like, or you can start here. It doesn't really matter. Just to make sure that when you have these branches here, that you write this stuff down and then the other branch down before you write down the conclusion that's gotten from the two branches. Okay, so you have to write this down first and this down first before you can write this down. And then you have to write this down first and this down first before you can write this down. Okay? Because we had ended here with this stuff here at the top, I'm going to start from here at this point. Okay? So, I'm going to write down here using the statement 3, not T, wedge, not S, and the statement 5, not T, okay, to conclude not S using disjunctive syllogism first, okay, after the 5, okay. So for line 6, I'm going to write my conclusion, which is not S, okay, and I got not S from 3 and 5, okay, using disjunctive syllogism. Okay, so that will be my justification. Then, before I can move down here to the conclusion R, I'm going to have to write this down. Okay, so here I was able to get the statement S wedge R dot T, okay, S wedge R dot T, okay, using the statement 1, okay, and the inference rule commutation. Then from here, I was able to get, okay, so here, then from here, I was able to get S wedge R. So that's my next line, S wedge R, okay, using this statement here, which is statement 7, okay, and simplification. So statement 7 and simplification, okay. Then from this point, I can conclude here R, okay. So I can conclude line 9, which is R, okay. And I was able to get R from the statement S wedge R, which is here statement 8, okay, so this is statement 8, and not S, which is here statement 6, okay, so statement 6. So using statement 8 and statement 6 in disjunctive syllogism, I was able to conclude R. So R is justified by statement 8, statement 6, and disjunctive syllogism, okay. Then, now that I have R, I have to go to this side of my proof before I can conclude this here, okay? And what I'm going to do, because I'm running out of room here, I'm going to erase the stuff that I've already written down, okay, up to R here, okay, so I can write down the rest of my lines up here, okay? So now I have to write down what's going on over here before I can write down my final conclusion. So here, what I have is basically the statement T, okay, that's being concluded from the statement T dot S wedge R, okay. So this will be, so my line number 9 is here, my line number 10 here, and the conclusion I got was T, okay, and I got that from premise 1, okay, using simplification, okay. Then finally, once I have T, which is now line 10, okay, and I also have R, which is line 9, okay, I can use these two statements as premises in order to conclude my final conclusion, T dot R. So my line 11 will be T dot R, and the justification for this will be premise 10, premise 9, and the inference rule conjunction. Okay, so now I have written down my entire proof. So here's my entire proof, which basically illustrates how we can go from these premises to this conclusion using valid inference rules. Okay, so this proves the validity of this argument here by making explicit the specific steps that this argument makes in terms of valid moves, okay? Okay, so now notice how this was a pretty long proof and somewhat complicated, okay? Here's the thing. it's gonna be the case that you're gonna have some pretty long, complicated proofs. Okay? Now, the key to tackling these long and complicated proofs is actually to practice, 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 and to memorize all the inference rules, because by memorizing the inference rules, those inference rules will help you think about and strategize the kinds of moves that you need to make. Okay? Because if you don't have those inference rules memorized, you don't know what's possible in terms of what you can do. Okay? So it's really, really important that you practice doing these natural deductive proofs. Another thing is, you should work starting with the simpler problems and moving on to more and more complicated problems. And your book, the homework exercises in your book, is actually really great at this. The reason why is because your book actually presents to you these inference rules a little bit at a time, okay? So you first get one section that presents 4, and then another section that presents 8, and another section that presents 13. Now, we're not going to go beyond 13 inference rules, okay? However, you need to be able to master these 13. Another thing that's really great about your exercises in the text is that they increase in difficulty, okay? So when you do the homework problems that are in the beginning of the problem set, they're a lot easier than the ones that occur at the end. So it gradually increases your ability to solve more and more complicated natural deductive proofs, okay? So I highly recommend that in order to practice these natural deductive proofs, you start with one section at a time, okay? Do some in the beginning, and as they get easier, okay, move to the middle, do some in the middle, and as they get easier, move to the ones at the end, okay? And make sure that you're able to get to the ones at the end, okay? Because on your quizzes, you will have some complicated proofs that you will need to solve, okay? Another thing is that some of the answers that are given in your book, okay, might be different than the answers that you actually came up with. And that doesn't necessarily mean that the answers that you came up with is wrong, okay? The reason why is that some of these arguments may have different ways to actually prove them to be valid, okay? So it's not the case with all arguments that you can only prove them to be valid one way. Some arguments you might have only one way to prove to be valid, and other arguments you might have multiple ways to prove valid, okay? So your book only gives you one answer of how to show an argument to be valid. But the argument that's given actually might lend itself to multiple proofs, okay? Now, if you end up with a proof that you think is absolutely right, that you didn't make any mistakes in, but it's different from the one that's given to you in the text, and you want to make sure that you didn't make any mistake, that your proof is actually a good proof, what you can do is post your proof up in the discussion session, okay? And I will comment on it, okay? I will let you know if yes, it's a valid proof, or no, this is wrong, or so on and so forth, okay? Also, anytime you have questions regarding natural deductive proofs, please make sure you ask. Okay, it is very, very important that you actually ask me questions, especially with natural deductive proofs, because it's pretty complicated. Okay.